And we're just going to take a look now at network topologies, the various ways that we can connect networks physically. The first one is what we call the bus topology. So we used to take a line like a coax cable and run it around the room and then hook our devices onto it. Here's an example of that. Here's a thin coax cable, and it would run across the room, our small network, and then we would plug that thing into each end of this little T here so that our computer could hang off of it. Another way we would do it is using the vampire tap. And you could just dig. Here's how the vampire tap works over here. These pins would dig into this thing and make the connection inside of here. At each end of this thing, you don't see it here, but at each end of this cable, we have to have a terminating resistor. And that terminating resistor is so that the signals won't bounce and come back again. So at the ends of these things, if I didn't do that, I would get a reflected signal, and then these guys over here would get confused because of that reflected signal. So you want to absorb the signal at each end of that cable. All right, that's the bus topology. The second one is the ring topology. And token ring, of course, was sort of the quintessential ring topology. Here again are those token ring connectors, big bulky looking things. Here's what the plug looked like. Looks a little bit like an RJ45 plug, but you can see this little extra slot down here, and they are bigger than the RJ45. The next one is the star topology. It looks like this. Here you have a central device. Could be a hub, could be a switch. So here I've got a central device and these things all coming off of it like a star. This is the most common way that we do this today. Here's a schematic of the same thing. The full mesh topology is where every device is connected to every other device. Now I want to point some things out. I'm going to go back here for a minute at these. How many connections do we have on each of these devices? Well, I only have one connector on each computer. Over here I've got two connectors on each computer for the ring. Over here for the star, I only have one connector on each computer. But for the full mesh, look at this. This guy here, there are what, 1, 2, 3, 4, 5, 6 of these devices, and this has 1, 2, 3, 4, 5 connections. So you just count the number of devices and subtract 1, so n minus 1. And that's how many NICs I would have to have on every computer here. Here is a switch. Now, switches, of course, already have a bunch of ports on them, so it makes it real easy with a switch to make something like a full mesh. You would not want to do it on computers. I don't want to have 5 NICs in here just so I can talk to 6 computers. So with switches, we can, because we have lots of ports on a switch. And so here are some switches in a full mesh topology. We can do a partial mesh topology. In this case, I've got some routers that are connected partial mesh. Now this guy here has 4 connections, but this one only has 2, this one has 3, this one has 3, this one only has 2. Here's another example of one. You see, I still have redundancy here. You see, the nice thing about this is if a line goes down, I can still get to that in a whole bunch of different ways. Now here, if let's say that this line goes down here, well, I can still get from this guy to this guy by going this way and then down here and then up there. So with the partial mesh, I still get some of that redundancy, but without the cost, without the expense of as many NICs and as many cables running all over the place. Finally, we have the hybrid topology, and hybrid, of course, is what it sounds like. It can be any conglomeration of all of them, and here's kind of a schematic of it here with a hub, a bus, and a ring all connected on there. That's it for our topology types.